In this world, we have trained our object detector entirely in a simulation environment, with the only real data employed being a bunch of real unlabeled images. By doing so, we can use the resulting trained model directly into the real world without any kind of fine-tuning and with a performance of 95 mean average precision. In order to achieve that, we combine two types of simulated data. The first one is generated by first randomly dropping 3D CAD models of the objects to be detected in a physics engine simulator called Bullet. By doing so, the simulated objects reach a stationary pose that is physically consistent to the real ones. After collecting 10,000 of these scenes with all the objects' poses, we use a ray tracing library called POV Ray to add the colors, lights, etc. to the scene. In this sense, the colors of the objects are randomly drawn from a uniform distribution center to a color believed to be close to the real one. Apart from the color, other elements that only influence the appearance that are randomized are lights, background, texture of the objects, camera position, and tilt angle of the camera. With all this randomization, it is expected that the reality appears to the model as another variation. Of course, the annotation is also automatically generated. Here you can see the mask used for each object for one concrete scene. For the second type of data, we took simulated images, but in this case without any kind of appearance randomization, and then refined it to look realistic by training in a cyclic GAN framework. For this training, we used 256 real images of scenes containing the target objects. Similarly to the simulated images, the angle and distance of the camera to the table is continuously changed from image to image. These are some examples of how the GAN model translated the simulated image into a more realistic looking. Note that the model has learned to add more strong reflections in the metallic USB socket and change the texture and color of the switch to be closer to the real object. By combining these two types of data for the training, the completely randomized simulated images and the more realistically refined simulated images, we achieve a good detection accuracy of 95%. This was a gain of 4 percentage points as compared to training only with completely randomized images, and a 8 percentage points gain as compared to training only with realistically refined images.